Hello, my name is Dylan, and this video is going to be a sort of a small report about my personal project to make a moving vacuum cleaner that can move and turn on its own without the help of any sort of electronic components. The idea came to me when I was applying for a Monash Equity Scholarship, and I had to remember my past back in the high school where I was tasked to make a robot for a competition, and my first idea was to make a robotic vacuum cleaner. So you can see my first attempt at a robot did not really go that well, to be honest. The moving part, the actual locomotion, was not that mobile, but the actual vacuum, the suction part itself, did work quite alright. And well, now that I've finished Muffy last year in 2024, and I had quite a bit of time on my hand, I thought, why not revisit the project? Maybe try to upgrade it further. Plus, this could be a good opportunity to show the people of Monash when, if I am lucky enough to be called for an interview, perhaps a little bit of my workflow and how I sort of do my work. So, with all that said, let's discuss some basics. Uh, while the idea came to me on the 10th of December when I was signing up for the Monash Equity Scholarship, work wouldn't really begin in earnest until around just before 2025, right after Christmas. Until that time, though, I busied myself with gathering supplies, including some of my old materials here, and buying some other new parts, such as this toy truck, which would prove instrumental to provide me with the wheels needed for the design, along with some Lego, which I thought I might be able to use in some other parts of the robot later on. Now, as work began in 2025, more or less, I took time to cut out the base of the robot, upon which I added these two uh, motors with double axes, hooked them up to some batteries, as you can see here, and then after a trip to Starbucks, I got this plastic cup which I used to make the suction to make the vacuum cleaner by adding a netting in the middle, and at the bottom I cut a hole, and using the head of a recycled plastic water bottle, I use that as a sort of catchment to focus the suction of the air and to catch all of the debris that are stuck within it. For the actual engine of this vacuum cleaner itself, as you can see, I made it using a piece of cardboard, and I cut four quadrants to allow for maximum airflow, and I use this 140 RPM engine connected to a 9-volt battery, the same battery voltage that I used for the engines to ensure for maximum power. And so this power ensured that the suction would be strong and that the locomotion will be able to handle any sort of weight restrictions that were placed upon it. And additionally, I had this caster ball, as you can see up here, this metal caster ball, which are mostly used for allowing 360-degree movement, which would be crucial to allow my robot to be able to turn later on. And so that is more or less it for the construction of the robot. This build took about 20 days, give or take, including the time that I spent waiting for the engines to arrive after buying them on Shopee. Anyway, we shall now move on to me doing some testing on the robots. And at the end of all of these recordings, I'll give a sort of conclusion for the things that I've learned along the journey of this project. On to the recordings. Alright, so for this first video of testing, I shall be checking if the suction of the vacuum cleaner is able to suck up these 7 white pieces of paper marked with some black ink to differentiate from some of the waste that is already present inside the container. I shall now turn on the robot. As you can see, the test has been successful. Well, now that we have tested that it can move and suction, we shall now test if we can achieve but the third goal, which is to make it turn on its own. Shall now start up the machine. Given that we aren't really testing if it can suction anymore, we're just gonna test whether it can turn. Okay. Oh. Oh. Well, as you can see, the test for turning did not really go so well. As such, I came up with two solutions, which I will show the results of in the following recordings. The first solution was to put an engine at the back of the robot, and the second solution was to add some wheels at the sides of the robot, in the idea that when it hits a wall, the robot will turn a little, and the wheels will take it the rest of the way to complete the 90-degree turn. The following recordings you'll see will showcase the results of this experiment, let's call it. And so that more or less concludes the amount of test footage that I've recorded so far. In the end, while I was not able to make the robot turn on its own, at the very least, it was able to move at a steady speed, and the vacuum cleaner component worked as intended. When discussing about the things that I've learned so far, taking it from the top, I have to say that I learned a great deal about weight management and friction. When it comes to weight management, when I tried to put the third engine and the battery onto the unit itself, the unit as a whole became too heavy to move, so I unfortunately had to remove it to allow continued operation. So the amount of load that the engines could bear was a very important factor to consider. Secondly, when it came to friction, before I used the plastic wheels on this unit, I tried to use this not robot, sorry. I tried to use these monster truck wheels from an old Lego set that I had when I was young. Unfortunately, the power from the engines was not enough to overcome the force of friction on the wheel upon the floor, so it could not move at all, which is why I had to resort to these plastic wheels in the end. And finally, the most important lesson I've learned is that of time management. If I had started my work sooner, perhaps on the 10th of December itself, I might have been able to find a solution to be able to allow the robot to turn on its own. But oh well, the past is in the past. At my stage, I still believe that I need more knowledge to be able to make the project work as I envision it to be. But given that I am going to Monash in this coming February, I hope that perhaps when I'll be able to learn much more, and who knows, I might revisit this project in the future with all the knowledge that I've gotten over there. Oh well, that's wraps up what I have planned to make for the video today, and thank you for watching, and have a good day. Bye bye.